Hello, everyone. My name is Oren Elias. I'm CoderZ's General Manager here at Intelitech, and I'm very happy to welcome you to Robots in the Cloud, Tips and Tricks to Use Cyber Robotics in your STEM class. Our speaker today will be Kathy Dasho. Kathy is currently the K-12 District Digital Learning Specialist for the North Reading Public Schools. She has been teaching middle and high school technology and robotics for the past 12 years. For those of you who are attending one of our STEM webinars for the first time, let me tell you a bit more about us. Intelitech has been a pioneer of robotics and education for more than 30 years. Our inspiring innovation, CoderZ, is an online learning environment that allows students worldwide to program virtual robots using 3D engaging simulations while meeting key STEM curriculum goals. CoderZ makes robotics for education accessible, affordable, and enjoyable for all, and it is fully compatible with the LEGO Mindstorms EV3. You can learn more about CoderZ's online learning environment by visiting gocoderz.com or by following CoderZ on Facebook and Twitter. A few technicalities before we begin. We will be recording this session and will share the recording with you and the other registrants after the webinar is over. We welcome your questions. To submit a question, simply type it in the question box in the lower corner of the GoToWebinar control panel, or tweet it using the hashtag STEMinars. Kathy will answer your questions at the end of the session. As we mentioned, you are very welcome to tweet about this online workshop using the hashtag STEMinar or the hashtag CyberRobotics and mentioning GoCoderZ on Twitter during and after the webinar. Okay, so let's get this webinar started. Kathy, the audience is all yours.
Hi. Thank you very much, Oren. Thanks so much for the intro. Again, my name's Kathy Dasho, and I've been teaching technology and programming here in North Reading for about 12 years, and robotics for the last 6. My title is District Digital Learning Specialist, and right now, after about 10 years in the middle school classroom, I now teach 2 classes at the North Reading High School, in addition to part-time technical support and professional development for teachers. About 6 years ago, our superintendent at the time had the vision to implement robotics in the curriculum. The first LEGO NXT kits were piloted in 6th grade only, then the next year added to 8th grade, and then finally 7th grade. This way, all classes were exposed to robotics before leaving the middle school. That first year, we took the 6th grade on a field trip to a robotics company, which conveniently for us was located close to the school. That company was Kiva Systems, which eventually got bought out and today is Amazon Robotics. The graphic on the screen right now shows an animated version of what the students saw on the tour. The tour was a huge hit, and it showed the students exactly how the robots processed their cargo and how they got around on the factory floor. And they even were amazed to see that these production robots had very similar sensors and were not that unusually compared to their robots back at school. I was also thrilled to find out just the other day that 2 of those students at the 6th grade on that tour have today been accepted to Worcester Polytech Institute here in Massachusetts, which is a big computer robotics college here. Eventually, we upgraded 8th grade to EV3s, Lego EV3s, leaving the NXTs to 6th and 7th grades. Currently, we now have EV3s in 8th grade and 7th grade with the NXTs in the 6th grade. I believe I first learned about CoderZ a year ago when we were hosting different companies and presenters for our Hour of Code Week. We had a presenter from the company in our media library classroom, and he had the students on Chromebooks utilizing the tutorials. I was first struck by how similar to Scratch it looked, and then how everyone in the room was concentrating on their Chromebook, totally engaged. Students only looked up to ask the occasional question to the presenter, otherwise they were completely immersed. I liked that because I looked around and observed that even the techiest students were really busy. A while after that, I learned that we were going to be allowed to utilize CoderZ for my middle school robot club and my high school change team, which is a high school group interested in technology, who also man an assistant help desk for the school. We'll talk a little bit more about them later. Since Scratch is implemented in our elementary schools, the Blockly language in CoderZ was an easy transition for our students. The color groupings were familiar, and the tutorial explanations helped transform my job as instructor to more of one of a coach. My students have commented that it reminds them of Scratch, so they already feel comfortable. Ty, a current 6th grade student, says that for him, CoderZ is fun because it reminds him of Scratch, which makes it, he thinks it's easy, and the simulation screen robot makes coding more like playing a console game. Since robot kits are expensive, our district, as you can see, is pretty fortunate in the numbers of the physical kits available. However, that being said, each year more students joined Robot Club, and we didn't have enough laptops or robots to really give each student the time they needed to practice coding with a robot. When CoderZ came onto the scene, this gave students the time and challenges they wanted and needed on a robot. Now they could either work on their own with the simulations or team up and work together. Something I've noticed in my robot classroom is that while working in a group collaboratively is the recommended method and desired, the dynamics in the groups don't always gel perfectly. Some kids just like to do their own thing, and sometimes there are the students who prefer to build as opposed to coding. There are also students on special education paths that need extra time to practice for comprehension. The flexibility of the CoderZ program being web-based gives these students more opportunity to practice, either at different locations in the school or even at home, whereas the other software is only installed at school. Robot education lends itself to project-based learning, since it allows students to gain knowledge and skills by working on an authentic or real-world problem. Try to say that fast, real-world problem. Students solve problems by collaborating and discussing the different ways to approach a challenge, whether it's getting the robot to drive perfectly straight by adjusting the motor speed, figuring out what is the right sensor to get the robot to park perfectly, for example. My students also use the engineering design process and iterative design to get the job done. In my middle school robot club, I have observed the students working together, and to be quite honest, some of them are anxious to get to the physical robot because they've had access to them already since 6th grade. but others are quite content to stay with the simulation until they get it correct on the screen. One student in particular, Jackson, a 7th grader, became immersed in the simulations and worked through all the tutorials, even getting ahead by working at home. That's him in the green hoodie right there in the middle. He loves robots and programming and always wants to be working on them. His methods, however, can be a little bit jarring. He loves to play Journey's Don't Stop Believing, full blast, while he works from his phone. Now you have to remember, this is an after-school club. Since he also loves the physical robots, I introduced him to Legos, which is a method you can use to download your program from CoderZ to a Lego EV3 robot. We have a space mat that was purchased for club activity titled Mission to Mars. There are 7 different missions for students to work on, from saving astronauts to launching a satellite to collecting rocks from Mars. Jackson worked on his program diligently, blasting Journey a whole while from his phone, while also designing iteratively until he got it to work correctly, pictured here. We actually did have an extra Robot Club session this week. Usually we have Robot Club every other week this year. But sadly, Jackson is moving to Pennsylvania. He begged to have one more Robot Club before he moved away, so we did it again this week. I assured him that this could be the universe's way of leading him toward his path, as Carnegie Mellon is in Philadelphia, which is Pennsylvania, where he's moving. This is another photo of a Legos robot collecting an astronaut to bring him back to home base. Speaking of Legos and CoderZ, I then had an opportunity to go to a Catholic Cristo Rey high school in Lawrence, Massachusetts, where a close friend teaches. This school provides college prep education for inner city poor students. These students do not have access to much technology, and I also needed some data for a class I was taking. To help defray the cost of tuition, these students do a combination of work study. So they actually go out and work at nearby companies a couple of days a week. And robotics is not an option in their curriculum right now. I brought in laptops and some EV3 robots. This school would be a perfect location for CoderZ, since they don't really have the money for expensive robot kits, but CoderZ could fill the bill. The students were enthralled, and this worked into a nice instance of combining coding with the curriculum. In their current curriculum, the students had been going over prepositions. So we had robots on screen, and some of the EV3s were put into motion, demonstrating the actions of prepositions. Going over something, under something, between or around something, beside a wall, etc. Showing the action of the prepositions was a great way of reinforcing the meaning of prepositions and getting some STEM concepts along the way. The other students in nearby classrooms were jealous that not everybody got to do it, but I'll probably end up going back. Here are some quotes from my own high school robotic class who used CoderZ. My plan for next year is to have the students use CoderZ first before we even get near a physical robot, to get acclimated back into programming at the beginning of the year, since most of them will be coming probably from just using a regular EV3. CoderZ will be a good introduction before we get into the VEX robot with Robot C. We also, at North Reading High School, we have a high school help desk called Change Team. It's a group of about 6, 7 students who love technology. So we meet twice a week during their power blocks and experiment with software programming, Raspberry Pis, and of course, CoderZ. They also get the opportunity to work over the summer where they help install updates on teacher laptops, desktops, and they have the opportunity to learn from our network administrator and do whatever else tasks are required in terms of technology needs. We were chosen this year at both the MassQ and Krista McAuliffe technology conferences to demonstrate CoderZ. These students are pretty advanced, so they especially enjoyed the Java counterpart to CoderZ, where one can view the Java version of the Blockly code. They were working on their presentation, and I was very proud of not only their collaborative effort, but of the diligence they showed. Their project was to create an example of CoderZ with Legos. They wanted to demonstrate the driving test, which of course was relevant to them at the age they're at right now, since a lot of them had gotten their licenses or had their license. Everyone pitched in, and as we know, this happens frequently in robotics. 2 students in particular zeroed in on the program and worked together, both at school and at home, to perfect the program. It really was a real-world challenge. They were trying to emulate the actual driving test that they had to do at the local registry. And I loved how at the end, right before the conference, one of the students, Michael, went over the entire program and made last-minute changes to make everything meet the requirements. Truly an instance of collaboration. In closing, I think Jackson, our student who is moving to Pennsylvania and is now in 8th grade, would give this advice to anyone interested in utilizing CoderZ and robots. Don't stop believing, and may the code be with you.
Thank you, Kathy. We have several questions that we wanted to bring up. First of all, can you tell us more about how cyber robotics is different than just coding with tools like Scratch or others, or robotics in general, and how that is different than just pure coding?
Well, the cyber robotics, I believe, is a lot more user-friendly for the students. And I think it's because you have so many good tutorials with instant help and you can try that again. I think it's much less threatening for the students. And the way I've done it, they can either work in pairs. And as I said earlier, there are always some students in the class who say, no, I want to do it on my own. So the cyber robotics is so much less threatening, and the ability to go over it as many times as you want, I think, is really makes it user-friendly for them.
Okay. You mentioned, I think, a little bit about teamwork and the pros and cons. Can you share more information about that with us, and what was your experience with teamwork when developing code versus working with the robot, pros and cons?
Well, teamwork is a great thing, but even whether you're working with a physical robot or whether you're working with the simulation, there always tends to be sometimes a more dominant wolf on the team. And what they have to learn, again, is that famous word, collaboration. They have to learn to share. They have to learn to divvy up, okay, I'm going to do this part, you're going to do that part.
Another question You've been part of classrooms and dynamic robotics clubs. How do you see the space for art in the approach for STEM? How do you see STEM and STEAM fitting in?
Oh, I think it's a perfect fit because you can always integrate the creativity into either the robot itself or the simulation. You can integrate. It works beautifully, and it actually that's a way to appeal to girls in the STEAM process. They could actually decorate. You can turn robots into animals. You can decorate them. You can have a challenge. You can put a simulated challenge on the screen where they could go after jewels instead of Mars rocks. You can. STEAM allows you to throw in creativity, and that I think that would appeal more to the girls.
Excellent. And another question. Do you have any examples or tips of how to recruit more students into engagement in STEM, and what has been your experience in the middle school and the high school?
Well, what we have here at the middle school, what we do a lot of times, we have a new school now. So we actually can put little advertisements like on the TVs that are around the school to advertise the clubs. But a lot of times it's word of mouth for the kids. When they find out what the kids are actually doing in the club, then more and more kids will start trickling in. So I try to make the challenges as interesting and innovative as possible, which is why, the mission to Mars was a big one that we did. But also, I've worked on challenges trying to make it more appealing to the girls. Bullying is a big thing in the schools for the past few years. And we had a coding challenge where they had to transform on the screen. It was called Mean Girls, and you had to transform them from being mean girls into nice girls using a simulation. What was kind of funny was I actually threw out that challenge more for the girls than for the boys in the class. And when the boys heard about it, they wanted to do it too, which I found hysterical.
So we had another question. Do you give students specific roles when working together? Do you pair them into the engineer creating a design, a programmer, and a project manager? Do they rotate? What has been your experience?
My experience has been that's really the Lego recommendation, and I think it's a good one. My experience is I've done it both ways. I've assigned people into groups, and then I've let the kids pick their own groups. And it seems like their personalities, they do tend to take over those roles almost organically. Almost organically, they take them over. So that's what I've observed, and I've been doing this for a while. So
we have another question here. You mentioned that you have used VEX curriculum in the past. Was this at high school? And how does this experience compare to using simulation and Lego robots?
Good question. This is our first year implementing the VEX at the high school level. And I do believe they have to be at least a sophomore. There is a huge difference. There's a lot more building. These VEX robots are made of steel as opposed to the EV3s, which are mostly plastic. So there's a lot more building going on. And I am observing there are 2 girls in my class. The rest are all boys at the high school level. And I do have to say the girls kind of hang back on the building end and kind of let the boys do the majority of the building. I did call them over the other day and I said, we were actually doing attaching encoded sensors. And I said, you really need to watch this. You really need to get more involved rather than letting the boys just do it. So yeah, it's a big difference. The challenges, I would say The coding of the challenges, if you look at it, is not really hugely different from an EV3 curriculum. I do tend to use, I like Carnegie Mellon's video trainers, which I do use. We do veer off from them sometimes, but they do make life very clear for the students. So I do like those.
Excellent. And another question is, does the platform come with any curriculum? And is there an academic pedagogical part within the robotics program?
Well, are we talking about CoderZ or VEX now? I'm not sure.
The simulation software. So I assume CoderZ.
CoderZ. Say the question again. I'm sorry. Sorry.
Is there any curriculum that is supplied with the platform?
Yeah, there's a whole curriculum that comes with CoderZ. Yes. Once you purchase it, yes. And yeah.
Another question was, what other challenges do you do besides the mission to Mars? I think you mentioned a few others, but if you can elaborate more.
Other missions we've done, again, in going to the MassQ conference, we saw a robot trying to climb over a pile of books. So currently, right now, some of the students in my robot club, which is middle school, are trying to get a robot, and this is quite a challenge, to climb over a whole stack of books. That's one of the challenges we've been doing. We've also added in they actually have an app on the iPad for the EV3 with those robots, and we've experimented with that also.
Another question was there previous knowledge required to use the platform for the robotics team? What previous knowledge did they have before starting the program?
Is this for the high school team? Are you talking?
I guess both.
I guess both. Well, yeah, as I stated previously, the previous knowledge that most of the kids had coming into CoderZ would probably have been Scratch. So the transition to the Blockly was really seamless for most of these students. Now, some of them, again, had Lego NXT background, but again, that's block programming, using the Lego block programming. So that would be what they had before they went into the CoderZ. So, I mean, I tell you, it was seamless. They loved it. They thought it was fine.
Another question, what skills within robotics, or how does robotics help students develop skills they would need for the future?
Oh my Lord. Robotics helps students because it forces them to A, solve a problem, B, work together, C, test iteratively, D, make a prototype. It's got all real world skills. One of the challenges we're doing in class right now is a minefield challenge, where they basically are obviously pretending they're defusing mines, and that's very real world. That could be used right now in the military. Some of the controls you can use on these robots are something that the military would be simulating also. So I think robot education, really teaching them to solve a problem, writing code to do it, learning to get along with people that you're in a group that you may not necessarily have thought that these are people you could work with, is an invaluable skill in today's workforce. One of the first things they look for, at least this is what I've read, is that people who can work with people. And that's what the team making or team building in robotics teaches you, how to work together as a team.
There's another question. Our school teaches Java, so could they continue to code in Java and use CoderZ to visualize robot movement?
Absolutely. Absolutely. That's what my high school students were most interested in, was the Java portion of it. And, I'm sure it's going to be developed even more fully as future goes on. So, absolutely.
There was another question relating to girls in STEM. I think we touched upon it somewhat. How do you suggest to recruit more girls at the high school level?
Well, I'm hoping again, word of mouth, that the girls are in my class right now will spread of their experiences. One of those girls, as mentioned, right, one of the girls that presented at the school committee, as mentioned, was accepted at WPI. So I'm hoping that the girls that this is a trend that starts spreading as girls realize that this is a very viable field. Right. And the other thing is that we've actually started to implement for the past 3 years is implementing more robots into the elementary level to start the interest earlier, before all that middle school, cool stuff kicks in. And I'm hoping also to maybe try a session of CoderZ at our 5th grade level.
Okay, we'll give maybe just one more minute for questions, additional questions. There was a question on the educational pricing for the CoderZ product, so we'll touch upon that in just a moment. Just want to give another opportunity, see if there's any additional questions.
Mm-hmm.
What else do you teach beside robotics?
Anything and everything, no. I teach web design at the high school this year, and I'm also teaching the VEX robotics. Those are the 2 courses I'm teaching this year.
And I see another question of what professional development resources did you use in order to become proficient in teaching robotics?
Okay. Well, when I first started way back with the NXTs, again, I live in the area north of Boston, so there are a lot of colleges in this area. So I've been fortunate in that a few years ago, as I said, when we started with this, I was able to attend workshops and summer training at the University of Lowell, which is, they're very up there with their robots. They have a whole robot center. I was also fortunate to attend some classes at MIT for more programming, more than robotics. And right now, WPI does offer teacher training during the summer on, I think they concentrate on EV3s. But there are lots of workshops available. If you the CSTA, that's one of the organizations that gives a lot of information on that. But whenever I saw something that was available on the robots, I went and attended it, whether it was during a school vacation, but a lot of them are often in the summer, obviously, so that teachers can attend.
Excellent. We actually have one more question. Where do you find new project ideas?
Well, I find new project ideas, again, from attending these workshops. I troll the internet. And let me think. There is a wonderful person. His name is Damian Key. I don't know if you've heard of him, but he's written a couple of books. And I've actually communicated with him online, and I've gotten a few ideas from his books. So between books, workshops, conferences. I mean, I got the idea from my robot club from when I brought the high school kids to the MassQ conference. I saw what another school was doing, having that robot traverse up over the books. So I said, that would be great for Robot Club. We're going to try it in Robot Club. That would be great.
I would add that we helped form a closed, exclusive Facebook group called STEM for All, STEM, the number 4, and all. And you can join there. We have over 600 STEM teachers and professionals, and it's always a good forum to get additional ideas and project ideas.
Yep, good idea. That's wonderful.
So thank you, Kathy, for this wonderful presentation. I enjoyed the discussion a lot, and I think our audience did as well.
Great, I hope so.
So to continue this great conversation, as I said, I recommend joining the Robotics and STEM for All Facebook group. And also stay tuned for details on our next webinar, which is titled Games, STEM, and Online Learning, How to Educate in the Digital Era by Dr. Leonard Anetta. And you will get this invitation very soon.
Okay, great.
Before we go, we had another question from the audience by Cynthia about pricing. I wanted to tell you about an end-of-year promotion we are having. So we are currently offering a heavily discounted classroom bundle, including our Coding Robots curriculum and 24 annual subscription to CoderZ for just $840. And if you purchase an annual license now, we will actually add in another semester for free. So you will be getting 18 months for the annual price of 12 months, meaning you can start in January and it'll run through the end of the school year of 2018-19. You can also try CoderZ for free by signing up on our website, gocoderz.com, for a free trial account. To take advantage of this special promotion, reach out to us for a quote through our website. On behalf of Intelitech and the CoderZ team, I want to thank you all very much for joining us today, and thank Kathy very much for her great presentation and your great participation. If you have any questions, please be in touch with us or post on the STEM for All Facebook group, and we will be more than happy to connect you to Kathy. Have a great day.
Thank you.